Hi, I'm Teacher Thomas. Welcome to A-Level Mathematics. This is the specimen paper for 9231 Further Probability and Statistics for the 2020 exam series, question 4. The number x of a certain type of seashell was counted at 60 randomly chosen sites, each 1 meter square, along the coastline in country A. The number y of the same type of seashell was counted at 50 randomly chosen sites, each 1 meter square, along the coastline in country B. The results are summarized as follows, where x bar and y bar denote the sample means of x and y respectively. And based on the given data, the requirement reads, find a 95% confidence interval for the difference between the mean number of seashells per square meter on the coastlines in country A and in country B. This is a confidence interval relating to a difference in means. Our first decision is whether we're working with Z or T. Given the sample sizes of 60 plus 50, we'll consider this to be a large sample. Those combined are 30 or more, so we're going to be working with Z. So for a difference in means using Z, we're going to work with bar x minus bar y, plus or minus our z-score. I'm going to note that as z sub alpha over 2. We'll see how that notation indicates how we work with the confidence interval in our requirement, times the square root of the variance for x over the number for x, the sample size, plus the ratio of the variance for y over the sample size for y. We'll begin by calculating the variance for x, the variance for y. The variance formula is in the MF19. The variance here specifically for x is the ratio of the sum that we're given, 4,341.6 over n minus 1. n, reading in the detail, we see is 60. 60 minus 1. This simplifies to 21,708 over 295. Exact value, which is what I want to use for the input back into my main calculation. If I get a decimal that I can't write as an exact value, I'm going to use the store feature in my calculator so that when I do my calculation, I'm not using a rounded input. For y, the variance is going to be the sum in the numerator, 3732.0. Y's count is 50. 50 minus 1, and that gives us 3,732 over 49. Now our inputs, x bar is given as 29.2. Y bar is given, these are our means by the way, the mean of y, y bar, the mean of y, 24.4. Plus or minus. Now we need a z-score. We'll look that up in a moment. Let's set up the radical as the sum of two ratios. The variance of x is 21,708 over 295. And that's over the quantity of x, not quantity minus 1, the full quantity. X is a quantity in n of 60. Plus the ratio y's variance 3732 over 49 over 50. Again, not n minus 1, n rather. Now we want to look up our z-score. And I'll note this over on the left. This is sort of input that we could get before setting up the equation. So I have my, let's say, my setup over on the left and then my inputs on the right. So I'm looking for a z based on, I need to know my confidence interval, 95% confidence interval. So I'm going to divide by 2. Now what am I dividing by 2? The difference, 100% minus 95%, is 5%. I divide that by 2 to get 2.5%. And that means I want a z-score of 0.975. Okay, so I'm splitting the 5% difference between the 95% confidence interval and a full 100% by 2 for my difference in means calculation. I'm working on a low end and a high end, thus the split to 0.975. In the z-table, I can find that value to be 1.960. Make sure you can find that value in the table. Then we'll go over to the right and fill in where we have that gap. Our z is 1.960. Before finalizing, I'll do one more simplification, which is this difference in means over on the right, 29.2 minus 24.4, is 4.8. And I want that simplification so that when I get my low and high values, the low end of the range, the high end of the range, I can see whether they're reasonable. If I ended up with, say, values of 15 and 25, something went wrong because 4.8 needs to be exactly in the middle of the low end and the high end. So this simplification here gives me an idea that I'm looking for something smaller than 4.8 and something bigger than 4.8. To the right of the plus minus, I'll go ahead and give a preliminary calculation as well. This becomes 3.250, going out to 4 significant figures, since that's going to be an input into my final calculation. And the result is 1.55 to 8.05. And this completes the requirements for question 4.